Dear students, under the topic graph theory, we are learning the concept of center of a tree. We saw the basic definitions where we learnt about the eccentricity of a vertex and then radius of a tree of a graph, and then we learnt about the central points and also the center of a graph G. Now here we have a theorem that states that every tree has a center consisting of one point or two adjacent points. In our previous video lecture, we learned two examples where in one of the example we learned that it had a single central point that was V3, and so the center of the graph G was V3. And in the next example we learned that there were two centers for a graph V3 and V4, and so the center of G was V3 comma V4. We observed that one this is a tree with center as 1 point, and this is a tree with center as 2 points, and we see that those 2 points are adjacent to one another. So in this theorem, that is what we are going to prove theoretically. That is, every tree will have a center consisting of either 1 point or 2 points, and those 2 points will be adjacent to one another. So we shall see the theoretical proof for this theorem. So first of all, we shall consider and represent a tree as capital T. So first step is, let capital T be any tree. So we are considering a tree capital T with P points. So the number of vertices in that tree we are going to take as P number of vertices, that is P points. So P should be minimally greater than or equal to 2. So minimum it can be 2 or it can be more than 2. So at least we should have 2 vertices in order to obtain a tree. So we are considering a tree with P points. So we know that every tree will have at least 2 endpoints. It can have more than 2 endpoints, but minimum it should have 2 endpoints. So let us write that. So T has at least, so at the least it should have 2 endpoints. For example, a path graph is a tree only. So if you see in a path graph, for example, if I show you here, so this is a path graph which is a tree in fact. How many endpoints are there for this? So this is one endpoint and this is one endpoint. So we see that there are at least 2 endpoints for a tree. The examples we considered has more than 2 endpoints. For example, here in this example, this is an endpoint, this is an endpoint, and this are also endpoints. We see that there are 4 endpoints over here. So at least 2 we should have. We can have more than 2 also. For example, in this graph there were 4 endpoints which was more than 2. So minimally there should be 2 endpoints for a tree. And we also know that in a tree, the vertices with maximum eccentricity will be the endpoints only. Because, for example, in this graph, this is the endpoint. What is the eccentricity of this? That is the maximum distance of this point from each of the points of this graph, each of the other points. With this point, the eccentricity is 1. With this point, the eccentricity is 2 because there are 2 edges in between these 2 points. For this point, from this point to this point, we have 3 edges, which means the eccentricity is 3. And this is the other end point. So there are 1, 2, 3, 4 edges in between these 2 points. What is the maximum eccentricity that we saw so far? It is 4. So the end points will always have maximum eccentricities. If you observe the examples that we learned previously also, the endpoints will have the maximum eccentricity. So if you see here in this example, the endpoint, this point had the maximum eccentricity 1, 2, 3, 4, 5. So the longest distance will be for the endpoints only. So therefore we can write that into words. So in a tree, The vertices with maximum eccentricity are the endpoints of the tree. Are the end points of the tree. What is the reason? I told you the reason. With maximum distance from a given point, it will be. The endpoints only will have the maximum distance from any given point of that graph. That is from a given point. The eccentricity which will be maximum. Okay. So now we will come to the theorem. We have to prove that every tree has a center consisting of one point or two adjacent points. So in order to prove this, what idea we are going to do is we are going to remove the endpoints and check the eccentricities of the other vertices, what happens to them. And again remove the endpoints of the resulting graph. And that is the process that we are going to do. Now, first what we will do, we will remove all the endpoints from the tree. So, now we remove all the end points from the tree. So, from the tree, we are removing all the end points. So, what will happen? For example, in this graph, these two are the endpoints. So, remove it. These two edges also will go away. So, we will be having the resulting graph as this. So, we observe that this resulting graph, for example, if this is tree T, this resulting graph is represented as T dash. And we see that in the resulting graph, we have again a tree. And the resulting graph T dash will also be a tree, and the eccentricity of these endpoints will be maximum because they become the endpoints now. So, if we see, and we can also say that the eccentricity of each of the points will be reduced to reduced exactly one less than the eccentricity of these points in this graph T. For example, this point, what was the eccentricity in this graph? 1, and here 2, here 3, here 1 2, the maximum eccentricity is 3, and so this is 3. Okay, the same point here has eccentricity 1 2, 2 only, so exactly it is reduced by 1. So we see that in the graph T dash, the eccentricity of each of the points will reduce exactly 1 less than the eccentricity of those points in the graph T. So let us put that into words. So I have written that into words. The resulting graph T dash is also a tree, and the eccentricity of each point in T dash is exactly 1 less than the eccentricity of the same point in T. So what we observe from this, we see that T and T dash have the same center. For example, the center of this graph was this vertex, and the same vertex is the center for this graph also. So we observe that the center is same. So therefore T and T dash will have the same center. So now like this, what we will do, we will keep on removing the endpoints. So what will happen if the process of removing the endpoints is repeated? We will obtain successive trees having the same centers as we had for T. And eventually what will happen, we will obtain either a single point or two points which are adjacent to one another. Now in this example, as we remove these two endpoints, the next graph will be single point. So for this we are obtaining a single point. We can also take another example where we will have where we will end with 2 points that are adjacent to one another. So now here 1 2 3 4 5 vertices we took. If we take 6 vertices for example, so 1 2 3 4 5 6 vertices, these are the two endpoints, remove it. And which is the center here? Now for this graph, the center is these 2 points. We will have 2 points as their center. If you understand the previous lecture, video lecture, you will definitely understand the concept of center. So these 2 points will become the center, and if you remove these two endpoints, the remaining points will be these points. Again the same 2 points are centers. Now remove these two endpoints. So when you remove it, you will be left out with 2 points only, which were the center, and those 2 points are adjacent to one another. So every tree has a center consisting of 1 point like this, or two adjacent points like this. So that is the theorem. So let me just put into the words. So I have written that here. So if the process of removing the endpoints is repeated, we obtain successive trees having the same centers as for the center of T. And if we eventually obtain either a single vertex or an edge whose two end vertices are the central vertices which are adjacent to one another. So that is what I explained you. So therefore, hence the center of T consists of either 1 point or two adjacent points. Let me again explain the same concept for the examples that we had. Now this is the graph. What are the endpoints? V1, V7, V5 and V6. These are the endpoints. Remove those endpoints. So if this is the graph T, if you remove those endpoints, these edges will also go away. So these edges also will go away and we will be left out with graph like this. So this will be graph T dash, which is a tree, and the eccentricity also the same, and the center is this V3 only. So V3, V2, V4 we have. This is the graph T dash that we obtained after removing the end vertices of T, and so the center of this graph is also V3 only. Next, again for this graph, the end vertices are V2 and V4. So remove it. We will be left out with only one vertex V3, and this V3 is the center. And so therefore the theorem holds for this graph, that is center of T consists of either 1 point or two adjacent points. For this graph it is only 1 point. And we can also remember that when the longest path, that is 1, 2, 3, 4, here the longest path is from V1 to V5, V1 to V6, which has 4 edges. So whenever the length of the longest path is even, then we will be left out with a single vertex. Now this example you consider. Now in this example the end vertices are V1, V8, V6, V7. Remove it. If this is graph T, what will be T dash? So after removing it, we will be these 4 edges will go away. So we will be left out with V2, V3, V4 and V5. This is T dash. So here I am writing. Okay, this is T dash. So this is what we will be left out with. Now the end vertices of this graph is V2 and V5. Remove it. We will be left out with V3, V4. And this is graph T double dash. And for this graph, the center is the same V3, V4 and they are adjacent to one another. So for this graph we have two centers. And if you see, the longest path has the length odd because 1, 2, 3, 4, 5. So the length of the longest path was odd, and we observe that we are left out with two vertices which are adjacent to one another, which are the centers. Therefore, the center of T consists of either 1 point or two adjacent points, and we also observe that it is 1 point when the length of the longest path is even. It has two adjacent points when the length of the longest path is odd. That also we can infer from this. So I hope this theorem you would have understood, and this is a very significant theorem in the examination point of view. So it is also good to mention those two examples whenever you prove this theorem. Kindly follow the upcoming video lectures for more concepts under graph theory. Thank you.